So, hi everyone. I think we're going to start now. Okay, so welcome to ArabWIC Tech Talks. So, ArabWIC Tech Talks is a series of online webinars about technology topics organized by the Program Committee of Arab Women in Computing. And so far we had two talks, one about open source technologies for the Arab world, and the second talk was about the Grace Hopper Conference for Women in Technology. And this is our third tech talk. It's about a very interesting and trendy topic, which is the Internet of Things. It's a topic I'm sure that you have heard about, but like the most of us, we don't really know deeply what it involves in terms of players and operations and platforms. So in order to shed some light on this topic, we decided to do a webinar about it, and we invited two domain experts. So our tech talk will be titled Demystifying the Internet of Things, and this is the goal of the talk actually. And we are going to have two speakers. As I said, two domain experts. So we have our first speaker is Sameh Ben Fredj. Sameh is an Internet of Things consultant and a data scientist at Xebia in France. She holds a PhD in computer science from Telecom and Alcatel Lucent Bell Labs. And during her PhD, we were working with the same supervisor. She was working on service discovery in the context of the Internet of Things. Sameh is also the co-founder of the Artificial Intelligence, Internet of Things, and Robotics meetup in Paris. We also have a second speaker, Gabriela Jacques da Silva. Gabriela is a software engineer working currently in the real-time data infrastructure team at Facebook in the Silicon Valley. Prior to that, she was a research staff member at the IBM Watson Research Center. And she worked there on the language and runtime of IBM streams. Gabriela also has a PhD degree in electrical and computer engineering from the University of Illinois at Urbana-Champaign, and her research interests are in fault tolerance, software dependability evaluation, stream processing systems, and distributed systems. Thank you very much, Sameh and Gabriela, for joining us today and for accepting my invitation and preparing the slides. And now we are going to start our talk. So first, Sameh will speak for around 30 minutes. Sameh, I will be moving the slides, so I will be unmuting you in a second. And when you want me to move to the next slide, please explicitly say next. And after this, Gabriela will be speaking about data platforms for the Internet of Things. And she will be using a cool example about the Tour de France. After this, we will move to a questions and answers session that I will be moderating, and during the session you can ask questions. Basically, you can raise your hand and I will unmute you and you can ask directly the question, or you can write it in the chat and I can ask it directly to our speakers. So I hope it's clear for everyone. So let us start with Sameh. So Sameh, I unmuted you. Do you hear me?
Hi.
Hi, Sameh.
Hi, everyone. Can you hear me?
Yeah, we can hear you clearly. You can go ahead.
Okay. Thank you, Rita, for inviting me for the webinar. Thank you, everybody, for being here, and I'm really happy to participate in this session. So today we're going to talk about demystifying the Internet of Things. And so next, oh yeah, I have to say next, right? To change the slides. Hello? Oh, thanks. So I would like to start with a quote from Mark Weiser, who is a professor in Berkeley University. And Mark Weiser in 1991 had a vision about the technology which is disappearing in everyday objects and becoming an extension of ourselves. And actually today, with the Internet of Things, we can see that his vision is becoming more and more real. So we have smaller devices which are embedded in everyday objects that we are using, like smart glasses, the Google glasses that the girl is wearing on the picture, or the smart bracelet or smart watch, which are able to connect to the Internet, send data, and receive data. So the Internet of Things is becoming really a buzzword these days, and even during the last year or the last 2 years. And but for most of us, maybe it's still a black box. So we hear about it, but we don't know exactly how it works, what are the main technological component in an IoT system, and also what can we really do with the Internet of Things. So that's why today I wanted to make, for people who want to really discover what the Internet of Things, I want to make a cool introduction to the subject. So for that I prepared a menu for you, the IoT menu. So next. So we will start with the appetizers, with the question what. So we will talk about what's the Internet of Things today, what are the users today, how is it growing, and then we will talk about the how. So how it works, what's an IoT system, what are the main technologies involved in an IoT system, but also I want to talk a little bit about how can I start my own IoT project if you are a little bit hacker and you want to develop your own connected objects. So how can I start my IoT project? And finally, I'm going to talk about the where. It's a little bit about the future. What's the vision of the Internet of Things? Where are we going? What can we have as future usage? And also what are the main challenges that we still need to resolve? So let's start with the what. Next. Thank you. So first of all, we need to define what the Internet of Things. However, today there is no common and unified definition for the Internet of Things which is shared among all the communities. Actually, each community is having its own definition, but they all agree about extending the physical world to the virtual world. Next. So recently, there is a definition that appeared in the Oxford Dictionary, and this defining the Internet of Things as the interconnection via the Internet of computing devices embedded in everyday objects and enabling them to send and receive data. So mainly, a connected object is a physical object which is able to connect to the Internet and is able to sensor the environment around him, like for the sensors, and also they can also do action on their environment like the actuators. For example, action on the door to open it or on the window to open it. Next. So today the number of these connected devices is increasing very fast. This is a picture from Cisco. Is a prediction since 2011 about the evolution of the number of connected devices, and they compare it to the evolution of number of people on Earth. So we can see that the number of connected devices to the Internet is increasing fast and is even exceeding the number of people on Earth. And by 2020, we are talking about 15 billion connected devices. Next. And also the complexity actually of these connected devices is increasing. So in the beginning we were talking about just RFID tags, but now we have started about connecting the sensors, and then connecting actually devices in my home, and then we were talking about connecting transportation, we talk about smart home, and we are now also talking about connecting the city. So really the IoT systems becoming more and more complex. And these are all generating a lot of data. So we are expecting in 2020 to have 35% of the digital data generated by the connected object. And when we talk about this generated data, we also talk about money. So the market of the IoT is really estimated to billions of dollars in 2020. And that's why now there is a lot of big companies who are also start to invest in the Internet of Things. So you probably heard about Google. Sure you heard about Google who bought Nest like 2 years ago for $3 billion, or Samsung who bought also an IoT platforms, Smart Things, for millions of dollars, or Cisco who recently this year bought also another IoT platform to be active in this domain for like more than $1 billion. But there's not only these big web players who are getting involved in the Internet of Things domain. There's also a lot of startups. So next.
Sameh, we are not hearing you anymore.
Next.
Yeah, I think we missed the slide. We didn't hear you
Oh.
for some reason. Sorry. Can you repeat it, please? Starting from the startups.
Okay, so can you hear me now? It's okay?
Yeah, it's okay.
Okay. So, but there's not only big players who are involved in the Internet of Things, but there's also a lot of startups who are being created. Every day we hear about a new startup creating objects or working on the the data generated by these objects, and they're also covering different domains. And talking about domains, next. Next. Talking about domains, actually the Internet of Things is covering a lot of domains. It's almost everywhere. And I would like to show you some real object and real application of the Internet of Things today. Next. So we can find the Internet of Things in my home, and we talk about smart home. So here we have some examples. We have some smart camera who are connected to the Internet so that I can see what's happening in my home while I'm working, or I can see if my children are back from school and if everything is okay at home. We have also smart lamp like the Philips lamp, which are changing colors, and they can actually verify from if I go to work, I can check if I switch off all the lights in my home. We have the famous Nest thermostat from Google, who can actually, I can fix the temperature remotely, and also he can learn and fix the temperature at home by himself. There's also some smart bells that recognize the person who is ringing the bell on my door and open it if it's recognized. There is a lot of connected thermostat to tell me if the temperature and the humidity and the quality of air in my home is okay. And also there's some cool actually thing that maybe is useful for me, for instance, like the power, the flower power from Parrot. It tells you when your plants need to be irrigated and give you a signal to go irrigate your plants every time. So you would not forget this anymore. Next. But the Internet of Things is also actually touching the healthcare and wellness domain. So there is a lot of connected object that helps me to monitor my physical activities and to see if everything is going okay, if I'm making enough effort per day, if and also see my heart rhythm or some characteristics in my body, like the smart bracelet or the smart watch. There is also some objects that helps me to sleep well, like the Aura lamp from White Things. Other object that is going to measure my blood pressure, and they can send this information to my doctor. I can also have some smart object for my grandma. For example, this is the last example where I can have sensors. I put them on the medicine box for my grandma, and let me know if my grandma took her medicines on time or not, or if she had her lunch on time or not. But next, but the Internet of Things is also, it's not only about in the final consumer, it's also about the community. And as an example, we have the smart cities examples. So this is the first picture showing a project from IBM in a city near Barcelona. So they actually used more than 3,000 sensors. They spread it in the city, and they made some experimentation where they measure the quality of air and measuring the quality of the water, and also they connected all the garbage so that they optimize the garbage collection process. They know if they need to go there to take the garbage or not. We talked also about smart grid, or how to optimize the distribution of energy in the city. They optimize the distribution of the electricity in the city. We also talk about connected transportation and connected cars to support the drivers and allow him to avoid the accident and give him more detailed information about the traffic. It's also, next, the Internet of Things is also actually touching the business. So we talk about smart business. So this is, for example, here we have an example of connected logistics. So I can know each time where is my product and what's the status of my product, and to know wherever it has been delivered correctly or not. We also can talk about smart agriculture. So this is a project in France where the grab, actually they have been connected, and we can know exactly where we should irrigate them to have a good quality of wine. But of course we can imagine this example to many other type of implementation. Next. So cool. So now we have a little bit an idea about what the Internet of Things, how it's evolving today, and some usage that we can see nowadays. But the question is, okay, so how it's working now, and what are the main technologies involved, and also how can I start my own project? Next. So the Internet of Things is actually as simple as that. So we have an object. Oh, sorry, I miswrite it. We have an object, and it's going to send some data through the Internet to an application, and we can actually make some actions from the application. We send it to the object. Next. But if you want to have next. Okay. But if you want to have a more detailed view about this system, we can actually decompose it into 4 main steps. So we have the first steps, which is about collection and action. Near the hardware part, we are near the sensor and near the actuators, collect the data or send the actions. After collecting this data, we are going to send them through the internet based on a network infrastructure to the cloud, where my where an IoT platform is hosted, and where we are going to execute actually this data. We are going to clean it and store it, clean it, and also process it in order to be able to visualize this data through the different applications. So next. So we are going to go a little bit deeper into each step and to understand the different technologies involved. So let's start with the first one, which is the collect and the data or send action to the actuators. So as I said, here we are in the hardware, mostly in the hardware part, the hardware level. So we have sensors and actuators.
Sameh, we are not hearing you correctly. Like, can you repeat from when you said we have sensors and actuators?
Open my door or my windows, and historically we talk about local network. Like, I didn't hear you.
Yeah, sorry, Sameh. We didn't hear you correctly during the part where you were talking about sensors and actuators. Can you just repeat this part, please?
Is it my network, or is it because of my network? I don't know why it's...
I don't know actually, because sometimes it's
Sorry.
and sometimes it just stops. But yeah, if you can just repeat from the sensors and actuators part, please. Thank you.
Okay, sorry for that. Okay, thank you. Yeah, so I said that in this part we are near the sensors and actuators. So we are near the hardware part of the Internet of Things. And these sensors and actuators are actually, for example, my temperature sensor, or my pressure sensor, or if I have a connected lamp or a door which is connected and I can open it remotely. So mostly these components, they have a lot of constraints in terms of data processing, in terms also of data bandwidth, and also in terms of autonomy. So mostly they don't have a lot of battery energy, so they need just to work a little bit and then stay still in idle stages. So for that, we need some communication protocol that can actually work with this kind of electronic devices. And here we talk about, and we have usually some protocols which use which are low energy protocols like like Bluetooth or NFC or Zigbee, and they're going to transfer this data actually to another component which is called the gateway. So the gateway is, sorry. So the gateway is an electronic and also software component, but it's more have more capabilities than the sensors and the actuators, and it's also able to do some functionalities like protocol translation from the local protocol to the internet protocol, and also they can do some first processing on the data before sending to the internet network. And next. So if we want to see some examples of these gateway, for instance, your phone is a gateway because it can communicate. For instance, here on the image we can see that it communicate with the Bluetooth and with in the Bluetooth protocol with the beacon, and it will send the data to your application. Or at home also we can have some home boxes that will connect with the sensors, and they will send the information to the server which is hosted in the cloud. So next. So today we have a lot of actually communication protocols. We talk about heterogeneity in protocol communication and the Internet of Things, and we can create different families of these protocols considering different criteria. So if you consider the criteria of the coverage, so we have what we call the home area network, which is with the network can not exceed 100 meters, like the NFC, the Zigbee, the Bluetooth. We have also some local area network which are a little bit wider, but also today there is a new types of protocol that we call the LP1, the low power wide area network, wide area networks like Sigfox and LoRa, who can actually cover kilometers, and we can there are now we talk a lot about it, and they are now called like the protocols for the Internet of Things. We can actually have sensors which are far from each other for like 40 kilometers, and they still can communicate together. And then they will use these antenna from Sigfox or LoRa, and then this antenna will make the conversion to the Internet network. Next. Nice. So now that we have connected these hardware part and we collected the data, so we need to transfer them to the cloud, and for that we need a network infrastructure, and also we need a cloud infrastructure, and we also need and we also need some communication protocols to transfer the data. So for that, there is actually a lot of communication protocols which are used in the Internet of Things, but I selected 3 main protocols that are now getting famous. So we know the very known, the HTTP protocol, the hypertext transfer protocols. But there is also other protocols which are more designed to work with constrained devices. So the first one is COAP, is Constrained Application Protocol. It's an application layer protocol used for resource-constrained devices such as the wireless sensor network nodes, and it's actually HTTP-like. So it's used to easily translate from the COAP protocol to the HTTP, and to simplify the integration of sensor in the web. The third one is MQTT, is a publish-subscribe based protocol, and actually is a lightweight messaging protocol that we can use on top of TCP/IP protocol. So MQTT is getting very famous in the Internet of Things, even became a standard since the end of 2014, and is an asynchronous protocol who really create low overhead and consume really have low energy consumptions, and is based mainly on 3 components. So we have the broker, the publisher, where it's going to register actually to the broker through a topic, and we have also a subscriber who is going to subscribe to a topic, so the broker will transfer the data in a synchronous way between the publisher and subscriber. And all these protocols, there is actually today many implementation of them. So there is open source implementation and also some enterprise-based implementation. So for instance, all the logos that you can see on the right part of the slide. So like, for instance, the first one is called the Cloud MQTT, is a free version of Amazon broker. There is also the Mosquito, which is an open source publisher that can be used easily. And the last one is the Californium, is actually also an open source implementation. There is an open source form and also an enterprise form for COPE implementation. Next. Okay, so now that we have about a little bit the hardware part and also how we transfer data through the internet, so we will talk about the IoT platforms. So when we send data to the cloud, we will send it to a software component that is called the IoT platform. So, and its role is mainly to store the data, and also there is other functionalities as service management. So manage the service related to the different object. Scripting. Scripting is mainly used to mash up services from different objects. So for instance, if I have a lamp and if I have a phone, so I can mash up my lamp with my phone so that when my phone is going to ring, my lamp is going to blink, for instance. So this is enabled to create new services by actually mashing different objects. We can also have functionalities as service search. For instance, now in my home, maybe I don't need a service search because I will have 10 objects, so I can find them easily and I can have them. I have the list on my phone. But imagine in the future, if you are in a building, or even if in your home you have like hundreds of objects which are offering services, or in a smart city where you are surrounded by billions of IoT services, so you need a way to find them. So today we have Google to find web pages, but how about finding IoT services? We need a protocol, we need a way to find them easily. IoT platform can also, of course, is also integrating some part for data management and data processing. So here we talk about the big data platforms, and also about adding some mechanisms for cleaning the data and for processing the data, or applying some mechanism like machine learning or real-time processing in order to extract the information that's going to be used by the IoT services. Next. So talking about IoT platforms, today there is a lot of these IoT platforms, really. There is now hundreds of IoT platforms, and they are actually mostly similar, but they can have some different differentiations in terms of how many type of connected objects they can support or can recognize, and also what kind of services they can offer on the data gathered by these connected objects. We even now talk about the war of IoT platforms, because each IoT platform is trying to say, yeah, I'm really the leader on the market, and I am the one that you need to choose. And this is actually creating I think is creating kind of defragmentation of the Internet of Things, because actually we will end up with a lot of IoT platforms, and we will end up with silos of the Internet of Things. And the idea of the Internet of Things is really to connect all objects and to have a homogeneous solution. So maybe the solution is more about creating a platform that is able to connect all the objects. It's just a remark. So next. And the fourth step is about visualization. Visualization is really an important part because this is how we can, is there where we can see the service offered by these objects. So this is an example of a smart office, and we have a different information displayed from the smart office. So for instance, we have a number of coffee cup consumed, the number of liter of water consumed per day, the number of time we open in the fridge, and the visualization should be really easy to understand, and also adapted to different support. Next. Next. For instance, here we have information about my physical activities, which are displayed on my iPhone, and here we have also another information about my physical activities displayed on the smartwatch. So the way the information is displayed and the service is presented is very critical to the usage of the smart object. Next. Cool. So now that we talk about main technologies involved in an IoT system, so what about you if you are a little bit hacker and you love develop things and code things? So maybe you want to start your own IoT projects. And actually now it's becoming more and more easy because we have all the components on the market, and the electronics is becoming very cheap. Next. So for the hardware part, you can easily use some platforms. Next. For the hardware part, you can easily choose some platforms like we can find the nano computers like the Raspberry Pi, and also some microcontrollers like the Arduino. So for the Raspberry Pi, the difference between both of them is that Raspberry Pi is really a small computer. So you can do high-level software development on it, and you can also do some electronic and plug your sensors and different components. For the microcontroller, it's really very limited. If you are newbie in electronic and you want to prototype quickly your object, it's better to start with the Arduino in order to connect your sensors. It's really easy, and it's based on a language called wiring. It's similar to Java. In the Raspberry Pi, you can code in any language you want it, but not any language, but you can code in many languages like in Python or in Java or in Node.js, and it's easy to use. You can also find You can also find easily a lot of sensors and actuators and for measuring everything, and you can create your connected object very easily. So the platform that I showed you in last slides is they're playing the role of platforms, that they will connect the sensor and also they will make the link to the internet network. So then you just need to read this data and use some open source IoT platforms in order to collect the data and visualize them easily. So let me show you quickly some examples of projects that we have been making and hacking ourselves. So here the FadoNet lamp actually is, we didn't want to buy the Philips lamp, which is for us a little bit expensive actually. Sorry, there's person from Philips, but we wanted to hack the lamp and made our own connected lamp. So we bought a cheap lamp from IKEA, and we used some Arduino Uno platform with the RGB LED, and we created a small server that we hosted in the cloud. And with this lamp, we actually can change the color from an interface, as you can see. And yeah, it's almost similar to Philips lamp. Next. We also had another project, which is the Nest Light thermostat. Instead of buying a connected thermostat, we also can make it yourself. So here we used a Raspberry Pi. We also used the MQTT protocol, and we used an open source cloud to host our server, which is Hariku, and we can send the information from the sensor, from temperature sensor, and visualize it as you can see on the screen. So all these, really you can find a lot of code on the internet today, and a lot of tutorial where you can follow them and easily create your own connected object. Another project Another project is the voting board. So this project that we have developed for this board to be used in conferences in order to make vote. So after finishing the conference, people go outside and they can use this board in order to make a vote. And for that, we used an NFC reader. So with your badge, you can identify yourself with the NFC reader, and you can connect protocol to the Vertex server. And in the end, we have the voting for the different conferences. And the last one is about the Smart Studio project. Next. It's the Smart Studio project, and here we used another platform which is called the Texas Launchpad CC3200 platform, and we wanted actually here to connect our working environment. So we have different offices, and also we have some meeting room. So we connected the meeting room and an office, and we put some temperature sensors, humidity sensors, and also we put some mobility sensors to know if there is someone in the meeting room, if it's occupied or not. And also we wanted to connect our coffee machine, so we know how much coffee we are consuming every day, and also be able to estimate the number of capsule of coffee that we need to buy every month. Next. So cool. So maybe now we are going to talk a little bit about the future of the Internet of Things. I mean, what's really the vision? Is it as it is today? What kind of other users we can have, and what are the challenges that are remaining? Next. Next. So today, as you can see, we are more in a way in a one-to-one interaction with the object. I mean, you have a person and it has its objects going to interact with it, or we can have two objects communicating together. But we are not really in a larger scale.
Sameh, we are not hearing you.
Scenario, but the real vision of Hi, can you hear me?
Yeah, we couldn't hear you when.
Hi.
Yeah, when we moved to the slide, we couldn't hear you. Can you just repeat the slide, only the slide, please?
Yeah.
Thank you.
Okay. Okay, no problem. Oh, I'm really sorry. I don't know why it's cutting. Okay, so I said that today the vision, I mean, as you can see from the main usage, mostly we are talking about one-to-one interaction with the object. So we have a user who has an object interacting with it, or we have two objects maybe communicating together. But it's still also a little bit, sometimes it can appear as gadget actually. If you buy some object, maybe you will use them and then you will leave them, and because they don't have a big impact in your life. But that's why in the future version of the Internet of Things, we are really seeking about useful use cases and how Internet of Things can really change our lives. So many players in this domain, they have vision about a large network of connected objects like this. Next. Next. So like this, like today we have a big network of computers connected together. Tomorrow we're going to have a big network of connected devices who are able to connect despite the heterogeneity of the different communication protocols, and also they can understand each other, they can send information to each other, they can also be smart enough to take actions and to be a little bit autonomous. We even talk about, next, talk about a smart system, about system of connected objects. So for instance, we can think about my home, which contains a lot of connected objects as a system, and be able to communicate with other systems like my office at work or my grandma home. And we can also imagine some future usage. Next. like the proactive assistance and recommendations. So imagine in your home you are able actually to have objects which are smart enough to take action by themselves. Imagine your phone, before you sleep you put your phone, and your phone is going to communicate with your alarm clock and send to the alarm your agenda, so your alarm knows exactly at which time you should wake up, because it knows your agenda. And when you wake up you have automatically your window which is opening, your best TV show which is already ready, you can watch it, and you also your best coffee which is made for you, and your maybe when you go out from home the lights outside is going to switch on just because they understand that you are going out from home. So there is a lot, it enables some energy, so we can actually have some energy, yeah, we can preserve the energy. And we can also talk about some remote health assistance and prediction of disease. So in the future you don't need to stay at hospital a long time. So with the connected object the doctors can actually follow your status, and they can actually bring you assistance, and they can contact you at any issue. Your doctor can also get information about your health, and for example for your grandma they can be actually they can be assisted by a doctor, and their data will be analyzed, and they can predict wherever they will have some heart, for instance some heart disease or not, some heart attack. Another future usage on the city level. Next. On the city level, where we will talk about the prediction of traffic congestion and delay. Imagine that we can actually predict when they are going to have traffic, and if there is any delays, and the different systems in the city are can be actually alerted by these possible delays. Like if there is a problem in a street, then the airports can be near the street can be alerted by that, and also different buses or metros can be alerted, and the system can be actually automatically take into consideration these delays and try to optimize the different paths. We talk also about a better management of energy and the environment. We can predict the pollution so that we can take in advance some measurement in order to avoid that. We also talk about better security in cities. There is recently I saw a project in the United States, I think in Chicago, where they're analyzing a video from a different camera, and they can predict whether or not they will have some crimes in this place, and the security is getting better thanks to that. But in order to be able to have this future vision of the Internet of Things that will really impact our life and really ameliorate our life, we still have a lot of challenge. Next. We still have a lot of challenge in order to resolve, like that data security. Next. Is it, yeah, like data security, which is a big issue. I don't want my object to be hacked, or I don't want someone to be able to connect to my home and use my different objects. We also talk about privacy. So we need our own data need to be private. We don't want to live in a Big Brother mode. There is also heterogeneity in different levels. There is a lot of heterogeneity in the Internet of Things, from the protocol level to the application level. So how to manage all this heterogeneity, and how to be able to, how to enable different objects to communicate together and to understand each other despite all this heterogeneity. And also there is another challenge about scalability of these IoT platforms, and also about real-time data processing. So today we are talking about processing data really near the sensors in order to be very quick to get the answers and to offer services to the user. So, well, next. So that's all for me. I hope it was helpful and useful. So thank you very much. And if you have any question, I would be happy to answer them.
Thank you very much, Sameh. It was indeed very informative session. I think so, and I think like everybody here learned something new through your talk. Now we are going to move to Gabriella, who is going to give us an example about how to use data processing frameworks for Internet of Things applications. I already have some questions here, but just we are going to leave the questions for the time being till the end, and at the end we are going to take all the questions. So please bear with us for another 15 minutes, maybe 15-20 minutes, and then we will take all your questions. Okay? So,
yeah, sure. Thank you.
Thank you, Sameh. I will mute you again. Yeah. And we'll unmute Gabriella.
Hey, Gita, can you hear me?
Yeah, I can hear you. You are already unmuted, Gabriella. Yeah, please go ahead.
Cool. So as you said, I'll talk about the data processing frameworks for IoT applications, and I'll focus. I'll tell this from the perspective of one specific application that was the Tour de France application. So just as a disclaimer, I'm currently a software engineer at Facebook, but this work is not related to Facebook. This is related to work that I was doing at IBM. So next. So quick overview of what I'll be talking about. First, I'll describe the Tour de France, and then I'll describe a possible application architecture that can be used to develop an application like this. And this was actually very similar to what was done for this Tour de France application. And then I'll tell a little bit about, let's say, the pros of using this edge analytics, which is what Sameh was just talking about, of pushing some of the analytics directly to the devices. Also a bit of the message bus, that's also a point that was touched by Sameh, and streaming analytics, which was used in this application specifically. So next. So the Tour de France, in case you are not familiar with it, it's this sports event that happens every year. And cyclists, they go all around France during 21 days, just doing this these segments, let's say, of this. In 2015, this was the segments that they have done, just like cycling all around. So you can see that it happens not only in France, but also in these neighboring countries, which in 2015 it was Belgium and the Netherlands. So there are about 200 cyclists that compete in this, and at each day there are about 4 hours of the event. So if you're actually a fan of this event, and even if you're someone broadcasting this, you can see that it's actually quite challenging to see what's going on, because there are 200 cyclists. They might be at different points of a given segment. And if you want to follow one specifically, right, if you're a broadcast, generally you'll be only following like the leaders of this race. But if you're someone that is a fan of a specific cyclist, you may want to know information about specifically to this one person and see how that person is doing, how that athlete is doing. So next. So what the Tour de France did last year was actually a pretty cool application and demonstration of this Internet of Things, is that they enabled this live tracker website. This was done by Dimension Data and in cooperation with IBM. So IBM was used, the backend products of this application were IBM products. So here you would have this website where you could follow individually each of the racers. So you would have a live view of each one of them. You could follow specific riders and see where they were, what was their speed. And one very cool one was that you could see what were the groups that were riding together. So if you are to develop an application like that, right, how would you approach this? As Sameh was saying, there are many, many frameworks to develop IoT applications, and it really depends what you're going to do, really depends on what are your requirements, like how much data do you have to process, and also how soon that data has to be available for whoever is consuming the output of your application. So in this case, because it's a sports event, it's real time, you really want the data to be available as soon as possible. So Gita, there's an animation, so if you can just, yeah, that. So just as to, before, just to give a sizing of how much data this application had to process for each of the stages of this race, which there are 21 stages, right, one stage per day, there was about 4 to 6 million events that had to be processed at each stage. And as I said, these events, the data about this had to be available as soon as possible so that you could follow very closely what's going on in the events, and it actually represents what's going on right now. So this information is available at the Beta Live Tracking website that you have the URL there. Currently the website only has some stats about the race, but if you were to visit this website when the race was going on, then you would see this screenshot. So next. So as I said before, of course, an application like this can be architected in many different ways, right? It really depends on how much data you have to process and how soon that data has to be available to the consumer. So in the case of the Tour de France, definitely there were two aspects that are represented here in this picture, which is the message bus and the streaming application, and also of course the devices themselves, which in this case are the bikes that have this GPS tracker and a couple other sensors. And here I added this extra component here, which are the edge analytics, which is becoming more popular also, as mentioned by Sameh, where you're doing the analytics directly on the devices. So if we are to think on the context of the Tour de France, then the edge analytics would be used directly on the local devices to do some, let's say, one possibility is to do some cheap analytics, right, that is being consumed directly by the rider. So one example that one can think about is that, let's say that the rider established a race plan with his trainer, right, and you can use the edge analytics to consume the current raw sensor data like your location and like your heartbeat, and correlate that with your race plan and see if you're hitting the checkpoints that you have established for yourself during the ride. And then, because, well, this is a sports event, so the person that is doing the actuation is actually the athlete, so maybe the athlete can start like going a bit faster, or maybe start pacing himself depending on the feedback that he sees from his heart rate, and see how he can adjust based on the feedback provided by the analytics. So the other alternative is that still in this one, yeah. So the other alternative is that the edge analytics is just like summarizing the data and then pushing that up to your remote servers. The second part of this application is the message bus, right? The message bus is really like, as Sameh was saying, this entry point, like this message brokers, right? So it's like this publish-subscribe system. So when the devices, they will push the data up to your data center, and other applications can subscribe to this message bus and consume that data to do some extra analytics. In this example here, there is the streaming application consuming this data, and there is also, I put as an example to illustrate these different applications, I put this ingestion process that might be uploading this data to a database so that you can do, for example, compare the performance of a given rider across different days. So this is not something that you would do in real time, but it's something that you can do, let's say, at the end of the day, and you can just use like a batch system to do that kind of analysis. In terms of the streaming application, then that one will be involved on doing things that will be displaying in real time, right, with low latency. So you can be like updating dashboards. For example, if you are a fan of a given rider, you can subscribe to receive notifications from when the rider hits some checkpoints. And then the streaming application, when it sees that a given rider hit a checkpoint, it can directly submit and send like an SMS to whoever subscribed to that rider. Another thing it can do is to expose that data to a database so that the website that people are using will fetch data directly from the database from to see whatever is going on the rents. The key thing here, the difference between the analytics that is in the streaming application and the edge analytics, in the application you can do analytics that are actually correlating information from multiple devices, right? So as the previous screenshot shown, one thing that was being displayed is like this clustering of which riders were riding together. So this is something that the streaming application can do, this clustering algorithm that requires more processing power and requires correlating data from multiple devices and then outputting that to the consumers, right? So in contrast to the edge analytics. So next slide. So the edge analytics, as I said, it can be used to pre-process data at the sensor side. So it's basically not using the sensor just as some dumb thing that is just collecting data and pushing it up, but really about pushing the intelligence to the sensor. So there are several things that can be done, which are like local filtering, right? So that we reduce the amount of data that is being pushed through the network. And also some sensor data correlation, so things that can be actuated on directly by the device. In this case, who is the Tour de France, the biker would be the one that is actuating, right? But we can imagine that there are some actuations that can be done automatically by the device. One thing to keep in mind is that they might have limited battery and limited processing power. So like the Raspberry Pi example that Sameh gave, in one of its editions, it had like 512 megabytes of RAM. So for many things that might be plenty of memory, but perhaps for doing some more powerful processing that might not be enough. And then in that case, you would be pushing the data up to your data center. The other very interesting scenario here about this edge analytics, and that it was the case in the Tour de France, is that there are some spots, right? You're riding throughout the country, and there are some spots that you might have no connectivity. So in that case, the edge analytics, it can be used to do some local processing. And then, for example, pushing up to the data center like a summary of what has happened during the interval that you had no connectivity. So this is a very interesting scenario. Other many frameworks, and like here I'm mentioning programming languages, also I mentioned by Sameh, like Raspberry Pi, you can directly use mainstream programming languages, right, like Java, Python, C++, and just use their standard library to write these edge analytics. One framework that was recently released is IBM Quarks. This one is like a mini streaming system, like where you stripped out all your things that you need to do in a data center. So where generally the streaming analytics, they are able to distribute the application over several nodes and provide fault tolerance, very fancy techniques. And in this case, IBM Quarks is like a really stripped down. You have none of this functionality that you need to manage clusters and distribution of load, but you really is a small framework to easily write these analytics in a stream processing fashion. And this is actually an open source project. Everybody can go download and contribute to this. This is now an incubation Apache project. So next. So the next part of the architecture is the message bus, which is this, as I mentioned before, this ingestion point. Here I put cloud infrastructure, but really it doesn't have to be the cloud. It just means that it's a remote server that is doing more powerful computation. So the cool thing about the message bus is that will make your data available to multiple applications. So instead of establishing directly connections from your devices that might be having to upload the data multiple times, you just upload it once to this message broker, and then multiple applications can go there and consume from that broker. In the examples before, it was both the streaming application and the database for doing offline analysis. The other advantage that message brokers have is that they can be configured to provide scalability by doing like data partitioning if you need multiple servers to host that data, and also fault tolerance, where you can configure different durability guarantees for the messages that are being placed on this message broker. There are many example systems that do this. Apache Kafka is a very popular one that started at LinkedIn. Now there is a company, a startup backing up from the authors of Apache Kafka. just to develop this product. Zero MQ, also used by Storm. MQ, IBM MQ Advanced, which does have the MQTT protocol managed by Sameh, and it was the product actually used to do the Tour de France. Amazon Kinesis is like a service for doing this, and also other open source projects like Apache ActiveMQ and RabbitMQ. So next. So that's okay. You can leave that one on. Yeah. So the streaming analytics is the key part here is that it can be used to derive insights with low latency and high throughput. The reason why streaming analytics can do that is one is that they process data as soon as data is available. You can do incremental computation so that not every time that there is a new data you have to recompute everything from scratch. And the third reason is that you can do all these analytics in memory. So the way that one generally would structure a streaming application is like this data flow graph, where the nodes of this graph are these operators that do data transformation, and the vertices are the stream connections that do the interconnection between two different operators. And what is flowing through the stream connections are called the tuples, which is actually the data that go from one operator to the next. A tuple is pretty much like a database row, where like it has a schema with the data that is coming through. And in this case of the Tour de France, the data that would be coming is like, okay, this is the data point referring to rider 100 at this given timestamp with this given latitude, longitude, given elevation, speed, and let's say the heartbeat of the rider. And then the streaming application would get this data about multiple riders and do the computation that it is supposed to be doing. As an example, the clustering based on the timestamp and the latitude and longitude for all of the riders and deriving which ones are in separate groups, right? The next slide. So the advantage of using a streaming platform, as everything, you can always write something from scratch, right? But if you reuse some of the existing platforms, two key advantages it gives is that it already has many optimizations and abstractions that enables to have parallel processing, and also they have some fault tolerance guarantees. So in terms of parallel processing, if you imagine this simple graph here, hit one click. Yep. So you can do data parallelism, where you're partitioning the data among different operators, and the different operators, let's say this aggregation operator here, is doing the same operation over different subsets of the data. So it's parallelizing, you're doing both things at the same time and then managing it to process your data faster. The second kind of parallelism that these platforms generally take advantage of is the pipeline parallelism. So for example, you can do both your aggregation and data exporting at the same time, just over an earlier segment of the data. So these are things that you will get, let's say, for free if you use one of these platforms. These platforms also provide tuple processing guarantees. So in case there is a node that you're using to process your data, if it fails, the platform will take care to either just restart automatically or replay your data if needed. It really depends on the processing guarantees that a given application needs. So the different guarantees that you can have are like at most ones, meaning that if you're processing a data, it crashes, you just restart and start processing the next one, and you might have some approximate answer. You can also have at least ones that if there is a failure, you can repeat the data, but maybe that data will might be duplicated on the output because you're reprocessing it. And exactly ones where some platforms are able to provide where you have both no duplication and an exact answer. So there are many systems that do that. IBM Streams, which was the one that I worked for many years, is one of. Streambase is also one of the first commercial streaming systems out there, which was based on MIT and University of Brown research, maybe around 2005, 2006. Apache Storm, which is an open source one, which I personally credit as being one that brought
stream processing to the mainstream. And also more recently, Spark Streaming, Apache Flink, and Senza, which is a system from LinkedIn. Next. So just as a summary, of course, that you can architect your application in many different ways. And even as Sameh meant, there's many IoT specialized frameworks for doing IoT applications. It all really depends on your throughput, your latency, also how much money you have, because it depends which of these frameworks you can afford. But there are many different aspects to it, right? There is the frameworks that will do your edge analytics, which is this simple processing directly on remote devices, the message bus, which will be this ingestion point, and your streaming analytics, which will enable you to do high throughput and low latency processing. So that's what I had for today, so I'm open for Q&A as well.
Okay, thank you very much, Gabriella. Thank you. It was a really nice presentation, and the application was really like very, very interesting, the Tour de France. I think it speaks to many of us here. Okay, so now let's move to the questions. I have a few questions, I guess, so I will start with Wala. Would you like, Wala, to ask your question directly? I unmuted you. You can go ahead. Wala.
Hello.
Hi, Wala.
I would like to thank everyone for the presentation. It was really great. But I want to ask about the platforms that the first speaker talks about.
Yeah.
How to choose the best platform? Is it depends on the Raspberry Pi, Arduino, or what? I mean the software.
Okay, so the question is mainly to Sameh about how to choose the best platform. So Sameh, I will be unmuting you now, so you can like reply directly if there are any questions. So how to choose the best platform?
Hi, thanks for your question. I just wanted to know, do you want to talk about the IoT platforms which can be hosted in the cloud or on a server, or you want to talk about the electronic platforms to connect your sensor? Is it about the hardware platform or the software platform?
No, I mean the software.
So you mean, okay, because actually the Arduino and the Raspberry Pi are mostly used for connecting your hardware. But if you want to talk about the platform which are used for storing the data, is this what you want to ask about?
Yeah, there was a slide on step 3 called execute.
Yeah, okay. So you're talking about
that's what I'm talking about, yeah.
Exactly. So the IoT platforms, yeah, there is a lot. And as said, Gabriella, it actually depends really on your requirement and your need. Many platforms today on the market, they will, when you read the different descriptions, you will say, okay, they're all similar. But actually, you can always test them. You have always a free account to test them quickly. And you can also take into considerations the different requirements. For instance, what type of object they are able to connect. Some platforms have already some partnerships with many object constructors, so it's very easy to, so they will recognize the object and they can quickly display, understand the different data sent, the form of the data sent by this object, and they will display the data associated with this object very quickly. You can also see how many objects they can actually handle. So if you want just a platform to use in your home, then you don't need a platform which is able to connect like thousands of objects, right? There is also some differences in the type services that they can offer on your data, what kind of data processing they can make. Are they able, for instance, to only they offer you services to visualize your data, or they can also apply some mechanisms like machine learning, like some maybe image even on video recognition. Some platform can do that, like the IBM platform Watson. So yeah, you can see the list of services that they can offer you, and also the price. The price can be a good criteria, because some platforms are really expensive to use. So yeah, these are examples of criteria you can consider in order to select your platform.
Okay, thank you. Appreciate it.
I would like to make one extra point, which is also the expertise of the developer, right, that is choosing. So maybe you have to do something real quick for a given project, which means that you're going to get a platform which you're familiar with the language and familiar with the concept. So this might be something as well that might play in when you choose the platform.
Yeah, that's a good point, actually, Gabriela. That's true, because some platform can be like plug and play, like really you don't need to do anything, just plug your object and you can visualize your data very quickly. And there is some platform where actually, yeah, they give you only some blocks, and you can develop the service you need, and you use the API, and they use the different services that they are proposing.
Okay, thank you very much. I really appreciate it.
Okay, thank you, Gabriela and Sameh, for the answer. Now we have a question from Mark. Mark, I will unmute you and you ask a question. Go ahead. Mark?
Can you hear me?
Yeah.
Okay, great. So hi, I'm Mark Oliver from Technische Universität München, and thank you very much for the talks, very nice. My question to both of you, or also maybe to Rita as well, for you personally, which is the IoT killer application? So the application that that could open the market, or that would be most relevant for you to see maybe in 5 years?
I can go first.
One.
Yeah, go ahead.
Okay. Yeah. So I think that it's a great question, in the sense that I think that everybody is also looking for what is the IoT killer application, because many of the companies, right, they're doing all these platforms and etc., but they're still searching for how, and as you said, what is it that's gonna make all this space fly? So yeah, I don't know what is the killer application, but I'm pretty sure that everybody's looking for it.
Yeah. Okay, I'll give my answer too. Actually, this is a really great question, and this is the question that everybody is asking. We're meeting companies and they're saying, oh, we just want to do IoT, but really we don't know what we want to do with it. Can you give us some useful use cases that we can implement? And actually everybody is looking for, the killer application. But because the problem is that, especially in the beginning of the IoT, we have you can buy some connected object, but finally it's like gadget, right? They're not really impacting your life, so you will play with them for 6 months and then you will just leave them. And this is not the purpose. I mean, for my opinion, I think that the useful use cases will be in industry, for instance, in healthcare. It's actually mainly when we talk about high scale, large scale of connected object, or large scale of connected sensors that are sending the data that we need to analyze the data and show the results. Like the application that you show us today, Gabriela, is very useful for Tour de France. I believe in this kind of application. It's application which are in the smart city, for instance, how to improve our daily life, how to give us the information very quickly so that we can gain time and gain money. How can we connect healthcare systems so that we can improve the health service? For me, it's not about buying a connected object, playing with it. It's not like about one single object. It's about many many objects which are communicating together and which are sending information, and we need to analyze the data sent by this object and offer new services. Yeah, this kind of application for me, I think they can be useful.
Okay, cool, thanks. And I don't know, I mean, I could also ask a second question, but maybe Rita, you have other people, so maybe take them first.
No, it's fine, Mark. You can go ahead. I don't think I have other people asking questions.
Okay,
I
cool.
have a few questions, but I will leave them to the end. You can go ahead, please, Mark.
Okay, then the other question would be, so the Internet of Things in its original form means more or less that you take all these devices, so you also showed the picture and you all connect them to the Internet, and so basically all of the devices could technically talk to each other. What do you think is the most promising topology? So will you have all devices connected to each other over the Internet, or will you more have decentralized aisles where locally devices are connected and then you might connect those decentralized aisles together?
Okay, I can start. Actually, the origins we were talking about in the beginning, there were architecture where we have a centralized a central point in the system that will collect all the data, or that all the objects need to communicate with the central point to communicate with other objects. But what I can see today is that we are going into more and more decentralized architecture. I don't know if you heard about blockchain. It's really about having some decentralized architecture where objects can communicate together directly, and also because of the scale. I mean, we have more and more connected objects, and imagine in the smart city scale, I don't think that a centralized architecture is better than a decentralized one. I mean, to be able to support the large number of connected devices and to be and to manage all these devices, I think that a decentralized architecture is the way to consider.
Okay, thanks a lot.
Sorry, Gabriela, do you have an answer or comment on Mark's question?
Well, not really. I agree with what Sam answered. I think it will also really depend on the application and how powerful the devices at the edge will be. Like, for example, for connected cars, right? Maybe these are more things that will happen in things that are in geographic proximity, because that's what might make sense. But for some other information, they might still push data up to like a central server that might be doing, for example, responsible for redispatching in case of a disaster and things like that. So I think it will really depend on the application and how powerful each of the devices will be.
And I think also an important dimension will be the privacy of the data.
True. I agree.
Okay, cool. Thanks a lot.
Okay. I had two questions actually. First question is about the protocols and the technology for communication between the sensors and the actuators and the gateway, and between the gateway and the cloud or the internet. Do we have the same protocols on both sides between the sensor and the gateway and the internet?
I'm not familiar with it. No.
You mean okay. Normally between the object and your gateway, you would use some low power protocols, energy protocols, as I mentioned, like for example Bluetooth or Zigbee or NFC. So these protocols, because they are very they don't need a lot of energy, they don't consume a lot of energy, and also they don't support high rate of the data transfer. So we just so this is what are generally used in a local network, and most of them, okay, they are also used for short range because they don't need a lot of energy, so they can just send the data for a short range in a short range. And despite now we have, of course, Sigfox and LoRa that they can do the wide area networks, but historically there are short-range network, low power energy network that will communicate between this object and the gateway. And then we have between the gateway and the cloud, we have the internet protocol. So we will use like I don't know, we can have like, okay, outside it's mostly the GSM, 3G, 4G networks, and they will, yeah, this kind of protocol that we are using.
Okay, okay. Another question that I had is that, Sameh, you said that there are a lot of different platforms, Internet of Things platform, and you think that at some point there should be some kind of standardization for these platforms. When do you think this is going to happen? Because, for instance, in the telecommunication world, we saw that at some point we had so many vendors that there was a need for standardization, and it had some benefits, but it also has limited.
Sorry, I didn't hear the last part of your question.
Yeah,
I couldn't hear you. Can you repeat it, please?
Yeah, sure, Sameh. I was saying that you said that we have so many different IoT platforms, and that you think at some point there will be a need for like having some kind of unification or standardization. It's nice, but like in the telecommunication world, we saw that the standardization had drawbacks, like it limited the innovation in this domain. What are your thoughts about like the standardization and the Internet of Things, when it's gonna happen, and do you think it's a good approach at this stage? And it's also a question yeah, for both of you.
Okay, so I will start. Actually, yeah, in the IoT, there's a lot of heterogeneity in every level, and also in the application level. And but for me, the question of standardization, this is really an old question. They're all trying to make standard for the Internet of Things in each level of the technology of the different I mean, part of an IoT system, but in my opinion, it's not really the right way, because it's really very hard, and it puts a lot of limitation to try to find the standard, and even it will create finally silos. It will not make the IoT as open as it has to be. Actually, for me, we have to talk more about interoperability. So how try to find a way to make different platforms, different protocols, different communication protocols communicate, be able to understand each other. So find a way to make them interoperable, and not really try to find a unique solution that will work for everything, because I don't think that this is possible, and I think that it's just a nightmare.
Okay, thanks. Okay, Gabriella, do you have any comment on this?
I agree with Sameh. I mean, I think this is just something that even for like other technologies which have been around a little bit longer, like just in this slide, like big data, right? There are so many platforms, and each of the vendors are trying to push their own solution, and if that vendor is not that successful, or if it is successful, it ends up being acquired by a different vendor, and then put it in a single solution. I mean, I don't believe in standardization, even considering that in this case, like so many devices and different solutions, that I think things will just evolve naturally, and I don't know, what standard probably wouldn't fly here. I don't know. Maybe at the edge side in terms of protocols, but not in terms of processing. I wouldn't bet on that.
Okay, okay. So thank you very much, Sameh and Gabriella. Really, it was a very interesting talk, I think. Okay, I don't think that anybody else has any questions. Anybody, if you have questions, this is the time. Yeah, I think Nader has a question. Okay. Nader, I unmuted you. Please go ahead. Yeah. Nader, I think you muted yourself. Okay. Yes, Nader, I think I unmuted you. I think you muted yourself. You just need to unmute yourself. Yes, you are.
Hear me now?
Yeah, we can hear you now. It's fine. Hi.
Okay. Hi, and sorry for this. I have a broken phone, so I'm actually still at the office, so I wasn't able to hear all the things that were said. But thank you for both speakers. It was very interesting. I had a couple of questions for Sameh. Like broad questions. So the first, so Rida, how is this done? Should I like say all the questions?
Yeah. Just ask them, and she will respond to it.
Okay. I think Sameh, you said something in the beginning of the presentation.
Sorry, I cannot hear you very well.
I can hear him, Sameh, so maybe he will ask
Okay.
a question and I will repeat them. Yeah.
Perfect.
Sorry for this. So I think Sameh, you said at the beginning of the presentation that IoT is extending the physical to the virtual world. And I was wondering, like, what did you mean by the word virtual? Because, I mean, to my knowledge, it's just extending the physical to a more physical world, actually, where the second tier of the world is able to process information in the first one. I don't know if my question is clear.
Okay, let me just rephrase the question, Nader, and you tell me if it articulates your thought or not. So he's asking that you say that the Internet of Things is virtual, like it's a virtual kind of virtual world, and he thinks it's more like tangible applications. Is that right?
Yeah, exactly. I mean, the world virtual. I just wanted to know, like, what did she really mean by this context?
Yeah, but what did you mean by virtual?
Sorry, can you just repeat the question?
Yeah, the question is that you said that like IoT is virtual, but what did you mean by it?
I didn't say exactly that. I didn't say that IoT is virtual. I said that IoT is more about extending the physical world to the virtual world. I mean, we make a link between what's happening on the physical world and we expose it to the virtual world. So everything happening on your physical object that before that they didn't have any existence on the web or in the internet or in a virtual domain. Now you can see it. Your lamp is, for instance, if they're switch on, switch off. Now you can see that through different applications. So the statue of your physical object can be seen on the virtual world. That's what I mean. I mean, we have really the image of the physical world we can find it on the virtual world. So we have a link. There is no separation between the two worlds. That's what I meant.
Yeah, clear enough, I think. Do you have another question, Nader?
I do. So when we talk about Internet of Things, do we necessarily talk about cloud computing technologies behind it, or is there any other software infrastructure that might process the data that is extracted, from the sensors?
Did you hear the question, Sameh, or I need to repeat it?
Can you repeat it? No, actually it's very low, the voice. I couldn't.
Yeah, it's fine. Nader said that when we talk about Internet of Things, does it really imply cloud computing on the software side, or we can have other software like platforms? I think the question is that we can have cloud computing, but also there are other platforms. But I leave it to Sameh. Sameh?
I can respond. So I fully agree with Gita. Even in the case of the Tour de France, none of those technologies are cloud specific to cloud computing. So in my view, here it just means that there will be a remote server. It doesn't have to be cloud computing. I think it just happens that many of the services now, just because of the trend of cloud, they happen to be cloud enabled, but I don't see any requirement.
Okay.
Okay. Thank you for answering, Gabriela, and thank you, Sameh, and thank you everyone for the questions. So I think we are done. We don't have any questions anymore. Okay, so thank you again, Sameh and Gabriela, for joining us. It was really a very interesting presentation. I will be sharing later on the slides. If you allow me to do it, I can put them in a PDF format. I can also share the recording also if you allow me to do it, and maybe I can write a small blog about this tech talk, but for sure I will share it with you and you will review it. So we can take this offline and yeah, we can exchange some mails about it. So thank you again, and everyone have a nice day or evening depending on your time zone, and see you in the next talk. Bye.
Bye.